Thank you guys. Can you guys hear me in the back okay? All right. So welcome to ChefConf. Welcome to my talk. Thank you for attending. I know there's some other talks going on and you guys picked this one, so I hope to make it worth your while. What I'm going to talk about today is Capital One's, we have an enterprise offering of Chef at our company, and I'm going to talk about the evolution of that design. So this is going to be part Chef conversation and then also part AWS architecture design. So should help you better understand some of the limitations of the previous generations of the architecture and then what we look to improve upon with the new architecture that we've gone to. So my background, I have a long Unix and Linux systems administration background, and been doing that for a little over half my life. And throughout that, always a strong focus on automation, as any person here who has been a sysadmin knows that automating makes your life a whole lot easier. So as that line of work has kind of evolved now into DevOps, so I kind of put the ops in DevOps, and a lot of a focus on infrastructure in my background. I manage an agile team that manages the Chef platform, so I have 3 engineers that work with me, and we lead the development of the Chef platform, the support, making sure it stays up, and helping the community out. We've got an enormous Chef community at Capital One. So we don't do a whole lot of cookbook writing because we don't simply have the resources to do that. So we rely on, all the developers tend to handle that aspect of it. We make sure the platform stays up. The broader team that I work under is called Shared Continuous Delivery Tools, and we support the tools that facilitate the continuous integration, continuous delivery pipelines at Capital One. So your Chef, your Jenkins, your Artifactory, your GitHub, your Sonar, we keep all those tools up and do development on them. And our development community consumes these services and builds pipelines around them to automate the movement of code from dev to prod. So a brief history of Chef at Capital One. I've been at Capital One for a little over 4 years and joined the Chef team about 6 months after its inception at Capital One. And when I joined the Chef team, we had Chef in our data centers. And so Capital One's been working on a data center exit strategy and getting entirely in AWS. So we're pretty far along that journey. And when I joined, we had Chef in 3 data centers. And my first task was to migrate Chef out of the data centers and get it into AWS. So in 2015, we got that done. And I'm going to talk about that architecture and its limitations, and then move on to our most recent redesign of the Chef architecture that we did. Took about a year, and we finished it last year and released it this year. So when I talk about the current architecture, I also going to call it the legacy Chef architecture. This is what we're getting away. This was our first venture into AWS. This is what a Chef stack looks like. So we have an elastic load balancer up front. Behind it sit 2 front-end instances, and behind that sit 2 back-end instances. And the Chef database sits on an EBS database volume, so that Postgres resides there. And if anybody has used this design before, you're probably using the Chef HA plugin that manages moving that EBS volume back and forth between the primary and then the secondary backend. So that's what we had been using for about 3 years. And we have 5 of these stacks. There's 1 for dev, 2 for QA. So Capital One resides in US East 1A, US East 1 and US West 2. So we have a dev stack in East, 2 QA stacks, 1 in East and West, and 2 stacks for prod in East and West. So that's a lot of Chef stacks to maintain, but it's worked for us for a while. Another thing that Capital One has, this is specific to us, we have what's called Rehydration. And the way Capital One handles operating system patching and security vulnerability updates is every 2 weeks we release a new AMI in AWS for Red Hat, for Ubuntu, for Amazon Linux, for Windows. And the expectation for compliance is that you cannot be on an AMI that is older than 2 months. So the creation date of the AMI. If you're on one that's older than 2 months, we have a tool called Cloud Custodian that resides in AWS that will find you and will shut you down and terminate your instance if you're out of compliance. So there's a little bit of pressure. If anybody's seen the movie It Follows back in 2014, it's a horror movie, and centers around the protagonist has a curse placed upon him, and there's always a monster walking slowly towards them, and the only thing you can do is run, and that's kind of how we look at rehydration. You go get rehydrated, and you're good for about 2 months, and then you got to get out of there again. So rehydration is a big factor in how we approach building our stacks and making them as automatable as possible, because we've got to be relaunching them every 2 months. In the context of this architecture, this legacy architecture, what that means is that when it's time to rehydrate, we stand up a new incoming stack that's on the newer AMI, and we have to take this EBS volume right here. This guy we kind of consider the golden EBS volume that contains all the cookbooks, all the node data, and we've got to graft it over onto this new incoming stack. And so in order to get that done, that takes about 6 to 7 minutes of downtime. We have that process automated, but at the end of the day, we've got to take downtime for it, and that's what we want to avoid doing. So that's one of the limitations of this architecture. Here's a whole list of other limitations of it. So we've got a whole lot of stacks to maintain, downtime during rehydration, and we have random failovers with the AWS backend. This EBS volume will get caught between the primary and the secondary backend, and the service goes down, and what we end up having to do is take those two EC2 instances down and then bring them back up, and it regains its sanity. But that'll just happen at random, and we have to intervene there manually and take care of that. Another limitation of this is these backend servers, in order for that EBS volume to move back and forth, they've got to be within the same availability zone. So you can't have your secondary backend in another availability zone, because the EBS volume won't move over there. You'd have to take a snapshot and restore it to that other AZ. So at the end of the day, you're limited really to one availability zone. Fortunately, during the time, we never lost an availability zone, so this never bit us, but that was another thing that we were looking to improve. Lack of scalability, because those backends have to, because the backends only one instance can have that EBS volume attached to it at one time, you can't scale that horizontally. So you can't have multiple backends having access to that EBS volume. Chef clients, if we were to lose a region, the clients would have to re-bootstrap to the other, to the west stack. So that's a manual process and would require intervention on our customers' behalf. And at the end of the day, this means we can't reach the resiliency tier that we want to reach. And another thing, the new instance class just came out that's a lot cheaper and then runs a whole lot better. And we can't use that because we have to use Red Hat 7, and that HA plugin does not work for us on 7. So that's our legacy architecture. These were all the problems that we were looking to solve in redesigning the architecture. And so that brings us to what we refer to as Chef HA. And this is what our new stack looks like. I'm going to go through each one of these layers, the web layer, the app layer, and database layer, and explain the things that we've done to improve the architecture. So this is now symbolic of one chef stack. So we've gone from 5 chef stacks down to 2. We are no longer worrying about regions here. So we wanted one endpoint for production and one endpoint for non-production. And what that gives us is that we have a west application side and we have an east application side, and they're all going to terminate at an east RDS endpoint. The big win here was when Chef released the support for an external RDS database. So being able to leverage RDS and the capabilities that has. All right, so this is the web tier. Up at the top, this is indicative of our users who are accessing it, the managed console via their laptop, and also the instances which are bootstrapping. They're going to hit one Route 53 endpoint, so that's going to be tied to, really that's one DNS endpoint, so chef.cloud.capital1, and behind that we have over here, this is going to be the east side. This is an east chef server application load balancer, and then a west application load balancer. And so that's two record sets, and we have a latency policy, latency routing policy. So if you're coming in from west, you're going to get sent down the west application side, and then if you're coming in east, from the east, you got an east client bootstrapping, you're going to go down this east application side. On these Route 53 record sets, we have health checks, which are checking the ALBs, the target groups that are associated with the ALBs. If there are less than one healthy instance in the target group, that health check is going to fail, and it's automatically going to send the traffic down the other application side. So Route 53 has really helped us out with building some automated failover capability. Down here we get to the application layer. So there's our ALB at the top at the web layer, and behind the ALB we have Chef Server EC2s, and we're now using an auto-scaling group for those EC2 instances. So that auto-scaling group is spread across 3 availability zones. And the auto-scaling, the Chef servers, we needed an Elasticsearch cluster to replace the Solar functionality that was provided in the older architecture. At the time that we were developing this, Amazon did not have VPC support for Elasticsearch, and that means that it's an external endpoint. And so at Capital One, to reach an external endpoint, we have to go through a proxy. And that didn't work for us because the Chef servers, they don't support proxy. So what we had to do was stand up our own Elasticsearch cluster within the same, within this application layer. So that is also an auto-scaling group, and it's also spread across 3 different availability zones. This Chef Utilities EC2 instance, that's something that we, it basically contains scripts that we maintain. So node cleanup. When somebody terminates a node in an EC2 instance in AWS, that node is going to be left on the Chef server. So how do we clean all those up? So every hour we grab CloudTrail logs and check for all the EC2 instances that were terminated in the last hour. We check for their existence on the Chef server. If we find it, we go ahead and delete it from the Chef server. So that's how we keep node sprawl to a minimum. Another thing that it does is everybody's got access to the managed console. We have LDAP groups that control which Chef servers you have access to, but you've also got to go ahead and create those users within the Chef database and then link those accounts. So we have scripts that run and handle creating those accounts and then making sure people get invited to the correct org. So that's the application layer. And down at the database tier, this is in yellow. The green is, again, the application tier. This is, again, we're using Route 53 here. So we have a single Route 53 record set that is pointing to the east RDS endpoint. And this is a multi-AZ RDS instance, and it's got encrypted replication over to a read replica over in west. So we got multi-AZ taken care of, and also we've got the ability to fail over across the region. Now, one thing that I'm going to demo here is, one thing we had to solve for was, how do you know when the right time is to promote your read replica to master? So you lose the region, and you lose your RDS instance. You've got to go in and manually promote that, that west read replica to master, and then have everything point back over to it. So the way that we solved that was with, it's not completely solved, but here's one way to tackle it, is that we used Lambda to get this done. So if anybody used RDS before, you have what are called event subscriptions, and event subscriptions are basically just events that happen within the RDS database. You can configure them to point to an SNS topic so that you can get notified when certain things happen. And in digging around with those events, we found one event code, event 31, which basically says your RDS instance is in a bad place and it has failed. And so what we did was we wrote a Lambda function that is subscribed to that SNS topic. And what it's looking for, every event that's going to get sent from RDS to that SNS topic, that Lambda function is going to ingest that event and check to see if it's event code 31. And if it is, it's going to go ahead and promote the read replica and update the Route 53 record set to point to that new West endpoint. So over here, this is my Chef RDS instance in East, and this is my read replica over in West. And you can see it's in a state of replicating, and I've got a nice replica lag of what looks like 5 or 6 minutes. So here's Route 53. Let me get over here. This got refreshed. And so here's my record set, and you can see over here it is pointing to an East. I know it's a little bit hard to read, but that's pointing to our East master RDS endpoint. So over here with Lambda, I have a test event configured, which basically has the this is a JSON blob that's representative of the exact event that would be sent over by the event subscriptions to our SNS topic. And I just lost it. Hang on. So we were able to figure out what this JSON looks like, and then we parse this with the Lambda function to determine, is it event code 31? And if so, what's the RDS instance that's sending us that alert? So I'm going to go ahead and run this. I don't know. I'm pretty sure this is going to work, and if not, I'm not going to worry about it too much. What I would expect to see after this Lambda function runs successfully is that this read replica would change from an available state to a modifying state, which means it's being promoted. And over here in Route 53, I would expect to see that this endpoint has changed from East to West, to the West RDS endpoint. So we'll see if it runs. Okay, of course it failed. All right, I'm not going to spend a whole lot of time. Let's see. Yeah. All right, I'm not going to worry about that. We're going to move on. But you get the general gist of what that Lambda function is capable of. You can completely solve the lack of AWS's ability to automatically promote that read replica. So another thing that in the topic of, let's see. On the topic back of rehydration, so I want to talk about how this benefits us compared to the old way of having to take downtime for rehydration. So the old method was what's called a blue-green deployment, where you're standing up a new stack and then you're switching over to that new stack. Now what we can do is called a Canary deployment, where our auto-scaling groups, what we can do is we can bring up new instances within the auto-scaling group, wait for them. Those new instances are going to be on our new AMI. And then once those instances are in service in the target group, it's going to go ahead and terminate the old ones. So at no point, it does that for both Elasticsearch and Chef Server. So at no point do we lose our service. We can do releases, we can do rehydration without any downtime. And we have a whole lot of confidence in it because we know that the auto-scaling group's abilities, they're not going to shut down our old instances until the new ones are in service. So it gives us a lot better feeling going into releases. All right, we talked about promotion, and one of the things that we do within our broader team is a standardization of how do we build this. And so the phrase we like to use is we like to eat our own dog food. So we're maintaining the Chef platform, so we sure should be using Chef to build our infrastructure. So we've written an Elasticsearch cookbook, we've written a Chef Server cookbook, and we're utilizing Chef Zero to, once we pull the cookbooks down from S3, when those instances come up, they're going to run that client and then execute the cookbooks and then either provision themselves as a Chef Server or as an Elasticsearch instance. So all of our other teams have adopted Chef as their automation method for that. We bake the Chef client into our AMIs, so everybody at Capital One provisioning an EC2 instance has access to the Chef client. So here's a list of the things that this architecture gives us now compared to the old one. We have only 2 stacks to maintain. That's less rehydration. That's less cost spent on EC2 instances. And we no longer have downtime during rehydration, and we get away from these random failovers that happen. So no longer is that EBS volume getting stuck back and forth between the EC2 instances, and we lose our application for a little while until we can get to it. We now can use 3 availability zones for what are stateless front-end Chef servers. And so we also gain the scalability. You know, if our Chef servers get busy, they reach a certain CPU threshold, they'll scale up, and we'll get another Chef server that comes into play. Another big win for our customers is the ability to seamlessly fail over regionally. So when we had the East and the West Chef stack architecture, you know, if you're bootstrapped to East, that East stack, that key relationship between the node and the Chef server is not going to be present in that West stack. So now that we have more of a regionally agnostic configuration, if we lose the East, you know, application side, those nodes coming in from East can just go down the West application side. They don't need to re-bootstrap. They just continue checking in like nothing ever happened. Twice a year, we are required to participate in an exercise where we simulate a regional failover. That's called our TREX exercise. And basically that amounts to, we just did our first one in February with this new architecture. And we did it manually the first time around, where we manually promoted the read replica in West, and then failed the East application side. So everything was directed down West for a full week. And so even some of the East clients that were still, our customers were using, they didn't really notice anything. There's really not that much lag time, you know, going over to West, because at the end of the day, you're just pulling down cookbooks and instructions, not large artifacts where you would really start to feel the pain of having to drag them across the country. We're going to be able to achieve a platinum resiliency tier, so we have RTO and RPO, so recovery time objective and recovery point objectives, that we are required to meet to get a platinum status. So Chef HA, we're well on our way to that. We can recover from a regional failover really in under about 10 minutes. And the RPO is really, at the end of the day, what your replica lag is. So if you have a transaction that hits the east side and then you lose the east side, however many milliseconds you have of lag time between that replication over to the west, that's really all you're losing. So that really just becomes seconds or milliseconds for us. So it's been pretty easy for us to get a platinum resiliency tier. And also now we got this all running on Red Hat 7, so we can use the new C5, M5, whatever 5 class that makes sense for you to use. So higher computing power and less cost for us. All right, multi-branch pipeline. So all of our tools this year are focused trying to get approved for what's called pre-approved releases at Capital One. And what that means is that if you build your pipeline robust enough, you satisfy all these gates associated with certain software delivery principles, like you're doing unit testing, you're doing functional testing, you're doing performance testing, security testing, all these things to prove that your code is going to test out, be tested properly, and make it to production without any issues. And so we're all building out our pipelines to get basically onboarded with PAR. What that's going to do for us is give us pre-approved change orders that we can do to deliver changes to the stacks, our Chef stacks. So we don't have to wait our 3-day waiting period for our change to get approved. We can do these changes during the day because we've proved via our pipeline that the code is sane and that there won't be any production outages. So the way we're doing that, we're using Jenkins file, and we're writing all sorts of Groovy libraries to handle all these different testing mechanisms. So static analysis, functional testing, all that. We're doing that within Groovy. All right, so the challenge that comes with migrating from an architecture like this, migrating off of an old architecture and onto a new one, there's a lot of nodes to try and move over. And pretty much everybody has to touch their automation to move from one platform to another. So this line below is an example of the line in our bootstrap package. So this is how you would bootstrap a Linux box. That first Linux instance, the first set of parameters, you'll see AWS East, AWS West, and now the bolded Chef HA parameter. Those first two were for our legacy architecture. So if you're going to bootstrap to an East dev stack, so the second set of parameters shows whether or not you want to hit dev, pre-prod, or prod. So what we're actively doing now is getting away from the AWS-East and the AWS-West options. So we're not really thinking of this in terms of region now because we've just got one endpoint for prod and one endpoint for non-prod. So the way that we're handling this is with the AMIs that come out, we're going to start taking away the ability to use either of those AWS East or AWS West parameters with dev, pre-prod, and prod. So we're going to make that a phased approach and start taking that out of the AMI. We're going to modify this bootstrap script to only start accepting Chef HA to begin with for dev, and then we'll eventually move on to pre-prod and prod. And we'll rely on our rehydration, the fact that every team in Capital One has got to be standing their stacks back up on a newer AMI. And so this is kind of going to organically move everybody over off of the old platform and onto the new one. There'll be some hiccups, but for the most part, it's going pretty smoothly. We had it as an opt-in service for a while for Chef HA, just to let people get their feet wet with it. But now, now that we're looking to decommission the old architecture, we're starting to force people onto it. And it makes sense for them because it's going to give them a, at the end of the day, their resiliency tier is dependent on, the lowest common denominator. So if we're a gold or we're not platinum, they can't get to platinum if they're relying on a non-platinum service. So the expectation is that Chef is a platinum service at Capital One. So that's what we've been striving to work towards. Okay, so that kind of covers client migration. Now, another trouble is how do you get all of your artifacts off of these 5 unique databases and into what's going to end up being, at the end of the day, 2 databases, one for non-prod and one for prod. So we use Jenkins jobs for our community to upload their cookbooks to the Chef servers. So we have a dev upload job, we have a pre-prod upload job, and we have a prod upload job. So what we did last year was we modified these jobs to, if you push to the dev server, behind the scenes we're going to be pushing both to the legacy database for dev and also to the new Chef HA dev database. So we did that for all 3 of these jobs. So for about a year, every single new artifact going forward was going to go to both the legacy and to the new architecture. And at one point we did a catch-up of everything prior to that. We dumped out every single cookbook, role, environment, data bag from the legacy stacks, the legacy databases, and then just manually uploaded them to the Chef HA databases. So at that point, going forward, those databases for legacy and Chef HA were going to remain in sync. Now, that sounds relatively simple and achievable. One of the things that we ran into was artifact conflict. So if you've got an East and you've got a West stack, not every team was writing their cookbooks to be regionally agnostic. So they would write the same cookbook, the same version for East, and then have the same cookbook and version for West, and they would contain different code. And when it comes to thinking about which of those cookbooks do you pick to go into your new non-region specific Chef HA architecture. So you can't pick one. It just doesn't make sense. You don't pick the East or the West one. So not every artifact was able to be moved over. And so we had to rely on the community to say, hey, before you start bootstrapping to Chef HA, check on, through the Manage console, make sure your artifacts are there. And if they're not, let us know, and then we'll look at them. And likely it's that you've got different code for the same cookbook version in East and West. And so it would be up to them at that point to refactor that cookbook and make it regionally agnostic, or they would need to rename their artifact like Cookbook East or Cookbook West, and then it would be able to make it into the Chef HA databases. All right, so I've talked a little bit about client migration. We're in the middle of this right now. At the beginning of May, we disabled the ability to use the legacy dev chef environment. So going forward, no new EC2 instances that are bootstrapped can go to that older architecture. And in June, we'll disable QA, and then in July, we'll disable prod. And so everybody's going to need 2 months to rehydrate. So we expect by the end of the year to be able to start looking at shutting down these older stacks. There are going to be some edge cases and where we have to address certain teams individually to find out, maybe they have exceptions. Some teams do have exceptions from the rehydration process. So we'll need to work with them individually, but realistically, by the end of the year, we should be able to get this old architecture shut down. One other thing that I wanted to talk about on the RDS front, a recent tool that Capital One has come out with. They've written their own open source homegrown software to handle self-healing. So if you want to, you have an alarm, you have an alert that comes out, an incident, and you know exactly how it gets resolved every time, but at the end of the day, you're manually getting on there and taking care of that. So they've created a new tool called SmartOps. And what SmartOps does is, for example, how we're going to use it is we're going to have a CloudWatch alarm, like in the context of this right here. So when I talk about read replica lag, so how long the read replica, how far out of sync it is with the master, we have had instances where the replication has broken on the AWS backend. So something behind the scenes goes wrong, and that replica lag will, before we notice it, has shot up to like 4 days. And it's clearly broken, and the only way to fix it is to destroy the read replica and then recreate it. So we now have a CloudWatch alarm in place that's going to monitor replica lag. And if it gets over a certain point, like 4 hours, whatever arbitrary number that we come up with that makes the most sense, we're going to trigger a CloudWatch alarm. And that CloudWatch alarm gets sent over to PagerDuty. And our SmartOps tool is integrated with PagerDuty so that you can write a runbook within SmartOps that is configured to take various actions based on what rule SmartOps received. So we've written a runbook that's going to go ahead and delete the read replica and recreate it. So we've been burned by this twice. Twice we've had Chef HA, once the non-prod stack went down, and then once the prod stack went down because replication was broken. And what happens, how that manifests itself, is that on the master RDS instance, the space gets filled up. The way replication works is that transaction logs, a transaction for every change that happens in the database that needs to be sent over to the RDS read replica, a transaction log is generated, and it ships it over to the read replica, and the read replica ingests it, applies that change to that database to itself, and then lets the RDS master instance know, okay, I got it, you can go get rid of that transaction log. So when replication is broken, those transaction logs start building up and building up and building up. And eventually, 100% of your space is consumed on your RDS instance, and your application is down. So we had that happen to us twice. The first time, we didn't know what happened. We didn't know replication could just break like that. We just assumed it's in AWS, it just works. And no, I mean, AWS is awesome, but it's going to have its bumps. So the first time that happened, we worked with support to go, how did this happen? And then they explained it to us, and so we knew about it. And then the second time that it happened, my team was out to lunch, and I got the alert, and I immediately called up my engineers and said, this is probably the replication that's broken, because we have we have an alarm for storage, free storage space on the RDS master. And when it gets down to a certain point, we get a CloudWatch alarm that says, look out, you've got 10 gigs left on your Chef database. So I called them up, and so they got in their car and went back home, or back into the office, and by then it was too late. All the space had been taken up on the RDS instance, and so our application went down that time for prod for 8 minutes until you delete the read replica. Instantly, after you delete the read replica, all those transaction logs are destroyed, and you get your space back. So now we're going to have that process automated so that we don't have to worry about us, having to get back and manually deleting that read replica and recreating it. So SmartOps, neat tool, helping us out there. All right. Conflict, talked about that. Future plans for Chef. We're in the process of getting over onto Chef Client 13. We were on Chef Client 12 kind of since the inception of Chef. And so we had Chef Client 13 as an opt-in service. Or, you could use Chef Client 13 if you wanted to. And what you find is that the development community is not aching to go in and refactor their cookbooks to work with Chef Client, a newer Chef Client, because there's a lot of deprecations that get introduced. So we're now having to put, kind of force them over onto Chef Client 13 because it's been end of life. Chef Legacy Stack decommissioning, I've already talked about that. We want to get rid of that older architecture. And Chef Automate. We've had several demos with Chef on Chef Automate, and we love the dashboard. One of the biggest things that we can see for us is that the community relies on us if their client run fails to come in and look at, hey, why did my client run fail? And we don't have access to every single VPC at Capital One. We have over 100 VPCs at Capital One, and we just don't have access to all of them. So we can't get on everybody's EC2 instance, look at their Chef client run, figure out what happened, and tell them how they can fix it. Not only that, but we don't have the resources to do that. But Automate has the ability for them, would have the ability for them to look at those client logs themselves and save us some time and save themselves some time too. And another thing we want to get done is look at Chef compliance for kind of handling the vulnerability testing at Capital One and being able to use inspec and codify those tests to be able to do security vulnerability scanning at Capital One. So that's that. Do I have anybody have any questions about all that?
Do you have all this documented?
Do I have it all documented? Every bit of it.
Can we get a copy?
Yeah, I'm happy to share it. I've shared the diagram at the very beginning. This I've shared with the Chef guys. So if you guys want to ask them, they should have it. And if not, feel free to contact me after the talk, and I'm happy to give you my email address and talk through any. We also have a UK chef, so they're not really associated with us. Like we're not the same, but we have the same goal. They're over in the different AWS region, but they're going to be adopting this as well.
What are you doing for Pivotal.pem and Chef Secrets? Because you mentioned that you're using Chef Zero to bootstrap the front ends.
Yeah. So
what are you using for the secrets? For
managing secrets? Yeah. So we just finished. Capital One has a new tool called Chamber of Secrets, which uses HashiCorp's Vault software. So that's really the direction that we're trying to go. We want to store our secrets in there. We just finished. So this RDS layer, this is a separate stack that we run, and just in the last 2 weeks, we modified the. By the way, this is all created originally with CloudFormation that does all this automation. And we just converted it over to Terraform. We've adopted Terraform as our standard. And so we just finished modifying that Terraform RDS pipeline to pull our secrets out of Chamber of Secrets, out of that HashiCorp Vault-based software. But yeah, we do have a solution for that, and we're all working towards that. It can be a tough thing to try to work through.
Are you running one organization, or do you have multiple organizations?
Good question. We use a flat organizational structure. We have one org for dev, one for QA, and one for prod. there are advantages and disadvantages to both, and that's the way it's been done since we started with Chef.
So that kind of touches on what I was going to ask, that your legacy Chef server strategy was divided among your logical environments of like dev, QA, and production.
Yeah.
Like what kind of human challenges have you encountered merging those all together?
Well, for this, I mean, going from 5 stacks to 2, we had to take our non-prod stack and just logically divide it into a dev and a QA org. So, I mean, that part was relatively simple. You're just configuring your knife.rb to look at a dev org instead of a QA org, even though it's the same physical, whatever you want to, logical stack, however you want to look at it. Yeah, not too many human challenges we've run into with it, other than the challenges associated with when you have a flat organizational structure like that. It's hard because really it's kind of a free-for-all in that org, and but you don't have the overhead of having to maintain all these different organizations for all these teams.
Yeah, so part of your rehydration strategy, like you are doing this AMI release, right, every time, like frequently. So how do you automate this release of AMIs actually?
There's a separate team in Capital One which handles the AMI creation. So they're called the machine shop, and what their responsibility is every 2 weeks they're going to roll out a new AMI. So they have their own process for generating those AMIs and getting them tested, and because Chef Client is baked into those AMIs, and also they use our bootstrap package, we have to work closely with them to make sure that our stuff is going to work with their stuff.
All right, that's time. Let's give John a big round of applause, and thank you for coming.
Thanks.